Good afternoon. My name is Brenda Grover, and I teach chemistry at Richwood High School in Ouachita Parish School District, Monroe, Louisiana. My passion is helping students to realize the connections from abstract chemistry concepts to more concrete real-world relationships. The hybrid group of students in 10th and 11th grade in the video are being introduced to the gas laws using next generation and Louisiana state science standards. We have been studying how kinetic energy affects the behavior of particles as they change from one state of matter to the next. Having covered liquids and solids, we are now covering the gases. The primary objective of this lesson is to have students realize that changes in pressure, volume, and temperature affect the energy of the particles in a gas and therefore affects their behavior. We began with inquiry, where students watched the demonstration and they then used Nearpod to record and discuss their inferences with each other. Following their inferences, I introduced a gas law and I asked them to record what they thought caused the changes in what happened in a short video. The students used breakout rooms to compare their findings with their peers, and following discussion, they were given a set of problems and asked to predict and graph their results. Later, they made predictions on trends discovered in their graphs. We repeated this process for each of the gas laws, and then we wrote a culminating paper describing how these changes affect real-world situations. Okay. Today, class, we're going to learn about a relationship between volume, temperature, and pressure of gases. Okay, that's the whole point of the lesson today. Is there a relationship between the volume of the gas, its temperature, and its pressure? And to do that, we're going to begin with a demonstration. And then after we do the demonstration, I want you to just write down for me what you think. And then we're going to go back and check some of those things and see if we're kind of on the right track before we move on with the lesson, okay? Now, so if I can do this at home, please use goggles, okay? So I'm going to take my can, and I'm just going to invert it in my cold water, okay? All right. Now, I want you to go to Nearpod, and I'm going to show you, I'll give you an opportunity to tell me why you think this happened or what you think should happen. Okay? Everybody here? Okay. Anything that you think, we're not worried right now about whether your answer is correct or whether it's incorrect. We just want to see if you're on the right track. If you have any idea as to why that happened to that can. Okay? Okay, we got some really good answers. Good. All right. Zoe, do you have an answer for us? You okay? One time, it's been in the past, I've gone and I've actually seen a video of a balloon launch. And I don't mean just the balloons that you use when you're doing the commemorative balloon, I mean hot air balloon launch. So I think that's an awesome thing. So I want to show you a little bit of a balloon launch, and then we're going to go back and we're going to ask some questions, okay? All right.
Space, we say that the air becomes less dense.
Okay, so did anything that she said in her explanation as to why that hot air balloon rise, did it match your explanation of why the can collapsed? Kinda? Okay, what do you think, Antonio?
Well, with mine, I guess you could say prediction or hypothesis, I was just thinking that the temperature of the water in the can was leveling out with the temperature in the water.
Okay, so you said they were leveling out? What do you mean by leveling out?
I forgot the name of it, but I know that when temperatures, they try to equal out. Like, let's say if you have a glass of water and you leave it out, then you come back, it's room temperature. Basically, it means that the heat from the room came and made the temperatures the same.
Okay, so you're saying that initially then that the water in the can was a different temperature than the water in the container? Okay, and they begin to level out? So how is that different from what she said? She said that with your hot air balloon, it's sitting on the ground, and then what happened?
When it heats up, the particles from the air that's in the balloon, they start bouncing around from the heat.
Exactly. So once I inverted that can into this hot water, those particles immediately, as you said, they did what? What was the term you used? Yes, they equaled out, or equilibrium. They tried to reach equilibrium. So those particles that were once very hot changed temperature very quickly. So they were no longer energized with kinetic energy hitting the side of the container. Now they've slowed down a whole lot. Now, this brings me to something called Charles's Law. Charles's Law says that a volume of gas, if you change the temperature, in other words, if you increase the temperature of a volume of gas, then the amount or the volume, the amount of space it occupies is going to increase. By the same token, if you decrease the temperature of a volume of gas, the amount of space it occupies is going to decrease. We increase the temperature of a gas, the amount of space it occupies increased. When we decrease the temperature of a volume of gas, the amount of space it occupies decreased. So he says there is a direct relationship, a direct correlation between temperature and volume. And here's Charles's Law. And the ones and twos are going to stand for initial and final. Okay? So the initial volume of gas, and I have this also on your Google Classroom for you guys that are at home. The initial volume of gas, if you increase that same volume, I didn't add any more air to the can. I just increased the temperature. It sped up the particles and therefore it increased the volume. Once I cooled that same volume of gas, that means that the temperature of that volume decreased, so those particles slowed down and they got closer together. So what if we look at a few, now, if you said there's a direct correlation, right? And direct correlation means, if I'm going to draw a little graph here on the board, and this is also on your Google Classroom, guys. There are a couple of graphs on there. If I were to put that on the XY axis, which way would my slope be? Okay, so as my temperature is increasing, as I'm going across that x-axis, then my volume is also increasing on the y-axis.
Right. So we want up.
So you're changing your mind now.
No, because I'm trying to.
Well, if you put it that way, it's gonna be going up.
Okay.
But you said that if the temperature of the air increases, the volume increases, so it'll go up.
So my slope is positive then, right? So as I'm moving up this y-axis and across this x-axis, then my volume is increasing with the temperature. So I have a positive slope. So what did you think happened, Isabella? And how did it relate to what you found from the video?
I think that the can has less air in it that causes the can to collapse in the cold water.
Okay. Because the air rushed out?
Yes, ma'am.
Oh, good answer, right? Now, I have a certain amount of air in this can, right? So the amount of volume of air that I have in this can is set for this amount of pressure that's on my can. If I increase the pressure on my can, what's going to happen to the volume of air inside? Ah, okay. So I won't have as much air inside, would I? Well, isn't that something? So with Charles's Law, if I increase the temperature, the volume increased. But with Boyle's Law, if I increase the pressure, the volume decreased.
That's like
Pressure outside the balloon will be greater than pressure inside. The balloon expands to try and equalize the pressure. Volume and pressure are inversely related to each other. When we release the vacuum, the
We're
pressure
going to pause for a
increases.
second. Now, did you hear what he said?
They're inverse of each other.
He said what?
They're inverse of each
They're inversely related to each other. So what does that mean? What do you think that means?
other. One increase, the other decrease.
So then what would that slope look like? If we were to draw Boyle's Law, you said volume and pressure are inversely related to each other? So what would that look like?
Negative slope.
A negative slope, because as one is increasing, the other is decreasing. Okay? So we've got a negative slope going on with Boyle's Law. Whereas with Charles' law, we had a positive slope. If one is increasing, the other is increasing. With this one, if one is increasing, the other has to be decreasing. Now, why do you think that is? And I want you to talk about that at the molecular level. What's happening at the molecular level? Calvin mentioned it, but what do you think is happening at the molecular level that's causing your pressure and your volume to be inversely proportional as opposed to your temperature? So take a minute. Okay, talk it over. Okay, so you think you have a good answer?
I think Joe do.
All right. So, Joe, would you like to share it?
Pressure packs things together, and volume is how much space something takes up. So if you have more pressure, then the volume will shrink. But if you had less pressure, the volume will grow.
So does everybody agree with Joe? You think that's okay? All right, let's see. Let's see if we can put Joe's analogy to the test.
When you take the foam ball and you squeeze it together, so the volume is diffused what you have right here.
So what would you do with that part?
It ain't no shrinking there.
So I'm going to give you a couple of marshmallows. So as you're adding pressure to your marshmallow, is the volume getting smaller? You have to add pressure from all around now. Okay? So you're increasing the pressure. The volume is what? Okay. And as you decrease the pressure, the volume is decreasing.
I
Okay.
play,
So,
like, when I play like basketball,
Uh-huh.
and like it be in the wintertime,
all right.
like my ball always, like in the summer, it'd be big and pumpy due to the temperature around it, making the air in the ball particles move around quick. But like in the winter, if you go outside and try to play basketball, you leave your basketball out long, the temperature in the basketball of the air in it is going to decrease. Like my ball becomes flat and the volume.
Yes, very good example. So if you were to stop someone and try and explain to them why this is important, you can say, wait a minute, look at your basketball. In the wintertime, your basketball is going to be smaller if you leave it outside because the temperature is lower. And in the summer, when the temperature increases, the amount of volume is going to increase in your basketball. Same thing with your car tires, as you were saying. Okay. All right? Does anyone else have anything they'd like to add? Yes?
So you know how, like, if you like how she said, if your tire on flat, but if you like, let's say you want to put air in your tire, it could, you know how if you put too much air in something, like it could pop or explode. Like
Too much pressure, right? The volume has nowhere to go. Okay, so guys, finish filling out your exit tickets, and thank you so much for today. I hope you learned about how volume is related to pressure and temperature. Thank you. Evidence that the lesson objectives were met was indicated in the student responses to the predictions of pressure, temperature, and volume changes. I found that students were adept at calculating changes and graphing data from the three variables when asked with word problems. As indicated in the lesson plan, students were given 2 scenarios to choose from and to write verifiable, evidence-based papers using their knowledge of the gas laws. After the lessons, students provided further evidence of real-world applications in their written assignments, describing how gases are affected by volume, temperature, and pressure in 2 different real-world scenarios.